Okay, welcome back to Wickerson Studios. I am finishing up school and I'm able to concentrate more on what I was happy to do, which is a custom C# and ghPython user object file. And I've done these in the past. I've taken a lot from scripts. This one happens to be from Raya ISA, dealing with breps, classes, curves. I'm not sure what that mesh is. What was that one before it? Make something. Let's see. What is that one? Probably just making drawings. Oh yeah, making a 2D drawing. Points, structs, surfaces, transforms, and vectors. And there's a lot of nodes in here, and I've taken them, I've scripted them out, I've made them their own user object, but I wanted to apply them. So what I've done here, as you can see here, there's a turntable. It's based on some very simple scripts to start. I will take everything off to start and select this. I start with a WS for Wickerson Studios curves, and what will I do with that? And what I'm trying to do in this node system, if you take a look, is generate a bunch of geometries. And the first one is fairly simple, that I want to take that initial geometry WS. I'll turn off everything else until we get down to it. I will just take that and put it to preview off. And you can see how the first kind of script runs. So what I've done is I said, okay, I've got this Boolean union to breps C script that you can click on, and it's not closed. You can actually see how to write it. And with Raya ISA's script, she adds all of this wonderful stuff from system IO all the way through to system using GHIO serialization. And she adds that to the more standard ones. And then she writes the script. And you can pretty much see that she's applying a basic Rhino common through C# nodes. And you can, once you have them there, you can play with them. You can alter them. But what I wanted to do was have listed my favorite brep ones that I've taken from Raya ISA, and here they are all the way from created solid brep. And I've taken these first few, I guess down to here, 1, 2, 3, 4, 5, 6, and I've made them so I can click where they are in my script. So as I double click there, it'll scoot over and show me, okay, there's an application of Boolean union to breps, which is actually the same. It's a little slower. It's not optimized in that script, but it's a little slower than using the solid union. But when you click solid union, you don't get anything. You can't really open it up and look what's in there. But if you do it here, you can actually get right into the script and find out exactly what's going on behind the scenes, which is using the brep create Boolean union, and it needs two parameters, breps and tolerance. So as long as you have those set and you've learned how to use C pretty well, and if you're interested in acquiring all of these nodes, which most of them are customized, they're online, you can script them from tutorials, you can find them on sources, or you can just go to my Patreon and sign up. What I'm doing is I'm taking a little bit of self-promotion, trying to make this worth my time and money. Basically, all these are free. I just ask people for a $3 donation if they want to support me in any way. And then over here, showing all, I've got all the repositories that are tied to C# nodes, basic nodes, advanced, and intermediate. And then I've got my own systems of customized nodes as well. And with that comes a lot of the custom nodes for playlists. And those are all tucked in my ghFile private repositories, which I'll put you on personally if you're interested. So there's a lot to do with C#, and there's even more to do with ghPython nodes, which I'm going to kind of mix up with this set. So we'll close that out. We'll show you how this works. So basically, I've got a node that I want to apply. Well, it's going to need breps. So I thought, well, let's just create some breps. I'll take my little name, WS. I'll throw it through a little bit of a move into an array so I can play with that and change it up. You can change it in the X direction, in the Y direction, in the Z direction. But if you change in the Y direction, things fault and you don't get anything out of it. Or you get an open brep. Actually, Y touches. What's the one that doesn't touch? X, Y, Z. I think when I put it in the Z direction, they're not touching. So you end up with more surfaces. You end up with two sets of 4. And that just makes sense because those are actually stepping up and they're not touching. So you can't really Boolean them together. So you're getting behind the scenes, playing with it, having a tolerance. So I like to leave it on X or Y in the motion. And then I'm able to pattern them together. And then instead, I have 2 branches with 1 item on each, which is actually joined this one and this one, which can become fairly interesting. So you go back to where that scoots, and you come down to the next one. I'm trying to use calculate area, volume, and centroid. So let's go there and see what that one's doing. And basically, I take the data out of that one, which is those contained breps. I bring them in as the breps. At times, you have to graft and you have to flatten things. Otherwise, these will crash out. They don't have any safety, even though the other ones will crash out. But these will really crash out and shut down your program if you're bringing data in in a miserable way. So make sure you save this file as you're plugging through it. This one's a recalculate volume, area, and centroid, and they mimic, of course, the area and volume node, and they show you all your data. And what's nice with this is when you use one of Raisa's scripts and you see how she puts it into these really nice formatted strings, you have outputs, whereas you didn't have those outputs while you just grab the area and volume. You're going to end up with information like this, but you actually end up with these really nice descriptive outputs from using a C# node. So the more and more you get into this, the better. So let's go over to the next one and scoot down, and this is going to be, and maybe I should show the geometries, what I actually have. Well, it's just data. So the next one, as we go to it, is going to be, you're going to want the vertices, the curves, and the surfaces from that BREP. So let's scoot over here and see what I'm doing, and this is where it gets interesting. You got all the vertices, which I can put on preview, and there they are. You've got all the surfaces, which are very interesting because they come out as not what's it called, like cropped or whatever it's called. You'll see that you get the squares that contain everything, and then the curves are actually the curves related to that. So you can jump into here, grab this, this, or this, and then you start funking around that geometry. So what I did was I took these points and I decided, well, what did I do first? I probably grabbed the curve, sent it to a dispatch, grabbed some list items, lifted it using a gene pool. This is just the way I think. So I don't want to keep getting that. So if I put this on preview, you'll see what I end up doing. I end up creating a box. Now, what one did I forget? Okay, I extracted the geometry from it, the vertices, the curves, and the surfaces. That's fine. Did that from the BREP, so that's the one that I first used. And then I jumped over here, and I said, well, let's make create a BREP box with it. So in creating a BREP box, just to see what I have, you can see over here, preview on, that those are the points that are going to drive this geometry. And this geometry is from playing with a little bit of a gene pool and having a lot of control, but also having a ton of control through what you add those points to. And you end up creating these really funny, awesome boxes that are lofted and changed from just the information coming out of WS. So that's getting into kind of a Wickerson creative mindset. Let's go back here and go down to create solid BREP, which is going to take everything and trying to grab, I'm actually going to grab some geometries you'll see here, and I throw that BREP through a kind of rotation, 3D rotation that plays on 2π, so I can actually play off of that form and generate it. I can step back in the range so it pulls whatever numbers I end up using. You can see you end up having some pretty interesting geometry by using C nodes that are all customized. You can jump in there and see how simple they are. This script is pretty simple. It uses BREP array. Solids is going to be because the BREP creates solids. You'll need a BREP and a tolerance. As long as you set that, you can dig into that and find out exactly what you're doing. And what I did for fun down here was I took the preview and I said, okay, what if we don't use the geometry of the box? Well, let's just use the geometry of the letters. And then I can kind of have fun with that. So I actually got into here, used this node that gave me vertices, curves, and surfaces, and decided, well, let's just take those curves and throw them through the same type of structure to see what would happen. That's the same type of structure that drives that geometry. So text based on geometry from string to points. So pretty interesting script. I'm going to start with that. Of course, the ones I haven't done yet are create BREP from edges, which will be curves. I'll do a BREP extract edges and or holes, and then I'll do find bounding box and center, find BREPs in solid, find BREP solid. So if you're interested in this will be the first script. And as we get into the second one, better just save that as custom C+ and GH userObjects 01. We will change this and save this one as 02, and I will slowly start loading these up on my GitHub as I apply these ones to a new type of geometry. But the main point is learning how to get into these custom nodes that you've created from scripting, because even when you deal with points, you can jump into the point tool. Well, let's just jump into the one I have here. So this is merge coplanar faces. You can actually get in there and see the script for doing that, which is actually if the BREP is true, then you're going to merge planar faces. So basically, you're seeing what is written behind the scenes in all those vanilla nodes in Grasshopper, and then you're able to get in there and start fudging things around and having a lot of fun. So this is navigating topology of a BREP, which is pretty cool. Faces, face surfaces, loops, 3D curve loops, edges. This one's getting pretty fun because then you see a breakdown of everything. And the scripts get pretty complex all of a sudden, but as you're learning C, you're going to want to see it applied to something for the designer and in the Grasshopper. And a great person to watch is Jose Luis. He'll give you a ton more. I've got them for Warsaw, I think. I've got the ghPython nodes. I don't know how many I've got here, but basically I've made up a system. These are kind of interesting ones that were tied to Unity. I've got another one in here. Let me think. Where is it? This one. This is from Jose Luis's sorting. So I've got one that's sorting XYZ, and then sorting optimizing, which I use quite often. And those are scripts that come from his Geometry Gems series, I think. And he's actually using a little bit of Grasshopper notation in here. And he has his runtime methods. Very good to follow through, Jose Luis. And I just signed up for the Discord on Parametric Camp. So I'm excited to where this might go. And I'm just trying to apply, show examples of it, make these simple for people to think about. What C means, how I can dig deeper into those vanilla scripts, and hopefully mix up ghPython nodes, custom nodes with C# nodes that you're making, and hold the geometries that you like. So that was it. All rotated through, and I think that's it. And I think I changed one of the data. I think I changed something here, but there's totally play in this system that you can jump in. My gene tool is a fun kind of thing because it really allows you to play off those shapes and generate these boxes. And I'm not thinking any different with C# or ghPython nodes than I thought when I initially was making geometries static in Grasshopper and parametric, static in Rhino environment and parametric in Grasshopper. But it's much more interesting to think computationally because this stuff just explodes. And so if you can think, with surfaces and breps, you can probably think with lines, you can think with points, and then you're thinking with data, and you're starting to derive things from some very interesting files. And I'm not a data scientist. I'm not a computer scientist. I'm a sculptor. So this is the way I like to come at it. Thanks very much for watching.